Imagine writing a letter, not to a friend, but to someone you'll never meet, living somewhere you can only dream of. You seal it in a bottle and toss it into a vast, dark ocean, not knowing if anyone will ever find it. This is the story of Voyager, a message in a bottle from humanity sent across the cosmic ocean. Voyager carries our sounds, music, and greetings, sailing on solar winds toward unknown shores. It's a testament to our curiosity, a whisper from our small world into the universe. In 1977 we launched 2 robotic explorers, Voyager 1 and Voyager 2. They were our eyes and ears, reaching out to worlds we could not visit. Built by human hands, they were destined for places no human has ever been. Their mission, explore the giant planets of our outer solar system, and then go even further. They were built to leave our solar system and become our first emissaries to the stars. Think about the scale. From our tiny, fragile planet, we sent a piece of ourselves on an epic voyage. These twin spacecraft are now the most distant human-made objects in the universe. They are pioneers, mapping the unknown beyond our planetary neighborhood. Voyager is more than a story about machines and science. It's about us. It's about our unending desire to explore and understand our place in the cosmos. Each Voyager carries a golden record, a time capsule of Earth's sights and sounds, images, music, greetings in 55 languages, our introduction to the universe. It says, "This is who we are. This is where we are from. We hope someday to meet you." It's a message of peace and friendship, sent on a journey that will last for billions of years. Voyager is our bold step into the unknown. It's a symbol of what we can achieve when we dare to dream. The story of Voyager is the story of humanity reaching for the stars, and it all began with a message in a bottle, tossed into the cosmic ocean. Why launch Voyager in 1977? Because the planets aligned, a rare event that happens once every 176 years. This alignment allowed a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune in one journey, a grand tour. Before Voyager, these worlds were just blurry dots in our telescopes. Voyager changed that, revealing their storms, rings, and moons in stunning detail. Voyager 2 launched first, but Voyager 1 took a faster path, focusing on Jupiter, Saturn, and Titan. Voyager 2 continued the grand tour, visiting all 4 giants. Each flyby was a precise dance of physics, using gravity to slingshot to the next planet. The information they sent back was revolutionary. We saw Jupiter's great red spot, Saturn's rings, volcanoes on Io, and the blue worlds of Uranus and Neptune. These distant points of light became real places, forever changing our view of the solar system. Voyager turned the unknown into the familiar. It rewrote our textbooks and inspired a new era of exploration. The grand tour was a journey we may never repeat. How do you send a probe billions of miles? Not with fuel, but with gravity assists, a cosmic slingshot. As Voyager approached Jupiter, the planet's gravity pulled it in and flung it onward at higher speed. This technique was key to the grand tour, making the journey possible in a human lifetime. Each flyby had to be perfectly timed. A small error could send Voyager off course forever. The planets became our gas stations, providing the energy for the next leg. This method is now standard for interplanetary missions. The success of these maneuvers was a triumph of mathematics and engineering. Commands were sent across millions of miles, adjusting Voyager's path with incredible precision. Voyager's journey wasn't just about discovery, it was about mastering the art of exploration. We learned to dance with the cosmos, not fight against it. Gravity assists turned the impossible into reality. After Voyager 2 passed Neptune in 1989, the grand tour ended, but the journey didn't. The Voyagers entered the Kuiper Belt and beyond, beginning the Voyager interstellar mission. Their new goal: find the edge of our solar system, the boundary of the sun's influence. We live inside the heliosphere, a magnetic bubble created by the solar wind. Scientists wanted to know, where does this bubble end? What's on the other side? As the Voyagers traveled farther, the solar wind faded and cosmic rays grew stronger. Voyager became our scout, mapping a new frontier of plasma and magnetic fields. Every day it sent back data from a place no spacecraft had ever been. The silence out here was different, filled with the whispers of interstellar space. The distances were staggering. Signals took hours to reach Earth. The spacecraft aged, their power faded, but they kept working. Voyager's mission became a voyage into the unknown, reporting from the edge of our solar system. It was exploration in its purest form. For years the Voyagers journeyed outward, sending back data as the solar wind slowed and interstellar whispers grew louder. In 2012, Voyager 1 crossed the heliopause, the boundary where the sun's influence ends and interstellar space begins. The number of solar particles dropped, cosmic rays surged. Voyager had left the cradle of the solar system. Interstellar space isn't empty, it's a thin soup of plasma, dust, and cosmic rays. Voyager 1 became our first direct sensor in this environment, measuring the true nature of interstellar space. In 2018, Voyager 2 followed, providing even clearer data with its working plasma instrument. Both spacecraft confirmed the crossing, giving us a more complete picture of our solar system's edge. They found the shoreline of our cosmic island. This was a monumental achievement, a quiet triumph billions of miles away. For the first time, humanity touched the space between the stars. Voyager's crossing marked a new era in exploration. We became interstellar explorers, if only through our machines. The Voyagers redefined the boundaries of home. One of Voyager's most surprising discoveries came from listening, not to sound but to plasma vibrations in space. As Voyager 1 traveled through interstellar space, it detected a persistent hum, the plasma singing in response to pressure waves from our sun. This hum allowed scientists to measure the density of the interstellar medium. We expected silence but found a dynamic, echoing environment. Solar eruptions sent shock waves that made the plasma vibrate. Voyager could hear these distant events. The data showed the density of space increases as Voyager moves farther from the sun, revealing a turbulent boundary. These details were impossible to know without sending a probe to listen. Voyager's journey became a deep space symphony, full of unexpected discoveries. Exploration revealed the hidden music of the galaxy. Sometimes the universe surprises us when we least expect it. The discovery of the heliopause surprised scientists. Its location and nature were not as predicted. Voyager's direct measurements gave us the true distance to the edge of our solar bubble. The boundary wasn't a clean line. The sun's magnetic field mixed with the interstellar field in a turbulent region. It's like where a river meets the ocean, complex and full of interaction. Voyager's instruments, built in the 1970s, were sensitive enough to detect these faint magnetic forces. This data gave us our first taste of the galactic environment. It revealed the magnetic forces that shape our galaxy and influence the birth of stars. With Voyager's crossing, humanity became an interstellar species. Our creation had made the leap. It's a profound moment, like the first steps onto new land. We took our first robotic step into the larger cosmos. The data Voyager sends back is our first postcard from this unexplored territory. The edge of our home is more complex and beautiful than we imagined. Voyager showed us the true boundary of our world. Voyager was built to last 5 years. It's been nearly 48. Powered by decaying plutonium, its energy fades each year. Engineers have shut down instruments to save power, a long, slow goodbye. Voyager 1 is now over 16 billion miles from Earth. Signals take over 22 hours to reach us. Communication is a feat of patience and engineering, using NASA's Deep Space Network to catch the faintest whispers. Every bit of data is precious, a final message from our most distant explorers. In the next decade, their power will run out and their voices will fall silent. But their journey will continue, drifting through the galaxy for millions of years. They are humanity's silent ambassadors, carrying our story into the far future. Voyager is our legacy, a testament to our moment in the sun. Why does the heliopause matter? It expands our perspective, showing us the true shape of our solar system. It's like seeing your house from the outside for the first time. This knowledge helps us understand how our solar system is protected from the galaxy. Exploration is in our DNA. We've always wondered what lies beyond the horizon. Voyager satisfies that urge, inspiring new generations to dream and discover. Its story is one of ingenuity and perseverance, built with ancient technology yet still working. Voyager proves we can achieve incredible things when we work together. Space exploration unites us, reminding us we all share this tiny, fragile planet. When we see images from Saturn or hear discoveries from interstellar space, we see them as citizens of Earth. Voyager's journey connects us to the cosmos and to each other. It encourages us to keep asking, where did we come from? Are we alone? What else is out there? The story of Voyager is the story of us, curious, hopeful, and always reaching for the stars. And the journey isn't over yet.